Hi, everyone, and welcome to today's webinar. I'm Devin Maguire, Product Marketing Manager at Cycode, and I'm excited for this conversation with Cycode's very own field CTO, Jimmy Zhu. We'll be discussing a persistent challenge in application security, the difficult and often time-consuming task of analyzing alerts to figure out which are exploitable risks that matter. So we'll dive into what exploitability analysis is and why it's important, the challenges security teams face analyzing alerts, especially at the speed and scale demanded by the AI era, and how customers are partnering with Cycode to tackle those challenges, quickly triage based both on risk and exploitability, reduce mean time to remediate, and improve risk posture and security outcomes. Jimmy, as always, it's a pleasure to be with you.
Thank you, Devin. Pleasure.
Before we dive in, I do want to encourage everyone to ask questions in chat. And with that, let's get started. So to kick things off and orient everyone around the topic of exploitability analysis, Jimmy, what is exploitability analysis and why is it important?
So before we get into exploitability analysis, I like to kind of level set a little bit, right? Not sure what audience we have today, but just outlay the persistent problem of application security in DevSecOps, right? One of the things that long debate between development and security, right, is the fact that, okay, developer write a piece of code, but from source code to assembling to artifact to deploying to production, there's a lot of possibilities where the piece of code written may or may not be vulnerable to attacks, right? So exploitability analysis is basically a estimation, in my opinion, right? Because nothing's for sure, of a point in time, how likely is that weakness or vulnerability in your application, whether it's source code format, or whether it's compiled binary, or whether it's deploying infrastructure, are susceptible for attack. Sometimes there are theoretical vulnerabilities. If you think about everybody nowadays talk about libraries and packages, right? Third-party library dependencies. There could be a package with known CVEs in your code or in your application. But the likelihood of that piece of library being loaded in your running application to a specific configuration, can increase or decrease the chance of being attacked. Also, there are other measures where one of the often debated discussion around custom code, which is typically picked up by SAST or DAST, is that I have a perceived weakness in my source code, but I've written mitigation, whether it's another sanitizing function in source code or a infrastructure security control or identity access control that are in line to mitigate the potential exploitation, then that reduces my likelihood. So that's, in a nutshell, exploitability, just to measure how likely or unlikely an attack could happen given the weaknesses and the environmental controls associated with it.
Yeah, so just because there's a vulnerable library or even like a reachable vulnerable function, the conditions for that CV to be exploited might not be met, kind of the recipe for that exploit. All those ingredients might not be present. And I know it's kind of a persistent debate in SAST of whether or not a code weakness is actually if there are mitigating controls in place. So kind of the difficult task of actually diving into that specific application context and use cases. Like, can this really be exploited in the real world? What's kind of the challenge of actually doing that analysis, and has AI amplified those challenges or issues, or what's your take on that?
That's a big question. The challenge, right, is it's very hard to do in a nutshell, right? In order to solve the friction, right, the security slowing dev down, right, we're not short of issues, right? AI in the case is AI is being used in development, which is inevitable, right? It's going to get better, just increase the velocity of code, right? Deployment, but also more magnitude, more lines of code. All that creates more opportunity for these kind of debates. So the challenge has always been how can we be for sure, right? There's always trade-offs, let's say. If you want to look at that, the best way to measure most accurately is look at a running application, but it's very expensive, right? You need an agent, you need to have a lot of compute power, you might impact performance to look at what's actually being attacked. But by then it's too late, right? So I'll just try to separate the two challenges around just say custom code, which is the code the developer wrote, and also imported code, which could be library dependencies, or any piece of code or artifacts or anything imported from outside. Let's start with the third party because that's what everybody talk about nowadays. A lot of R&D happening because you can have very specific versions of a particular library, right? You have a big package that has small little packages, direct and direct dependencies. But when you look at what piece of that library, the major version or small piece of components being used, it's very difficult to do that, right? Already. Let's say if you do, you still don't know based on the conditions, right, of your application, right? Conditions of how the code is written, how these libraries being used, called both at source code level or being loaded in memory, or there are environmental contexts, right? There's the repository, there's the directory when the code is running has additional compensating controls. You don't know those answers, right? The best you can guess is using today for exploitability is looking at public available data, right? Such as the EPSS score. Nobody talk about the pure CDSs anymore, but there are CSS Kev, the other predictive stuff, but those are very predictive. You don't know for sure. Or you can run an agent, which is very expensive. Nobody wants agent. For custom code, the problem is again, this is the debate of people talk about is SAST dead? Well, it is dead in a sense of the nurtured approach because you can look at lines of code, you can say, well, this one is vulnerable for injection attack, but how do we measure how likely that injection attack succeeded? Well, you got to look at there are other conditions, right? This public facing. Are there other permissions on the access to the database? There are other variables that makes this vulnerability. Is it to distinguish between is it an attack that can be easily done with all the requirements from the hacker, or does it have to go through 5 different roadblocks? So it's the context that's missing makes it very difficult for custom code.
That makes perfect sense. So we're gonna show the AI exploitability agent soon, but before we kind of get into the actual product, what's kind of AI's everywhere? What's your take on Cycode's approach to AI, whether it's agentic AI or otherwise?
Yeah, I'm obviously I've been a practitioner for the audience for 20 plus years. I'm very agnostic, but I'm biased now. I think that here's a little secret I'll just share, right? This is obviously why I'm excited about to show everybody. So AI or agentic AI in this case, I mean, we're still early as industry, right? So I mean, there's realistic expectation what AI can do, AI cannot do. AI can do, you got to train the model, right? People talk about the better the model perform or the worse model perform is based on the data you use to train the model. As far as AI agents, right, you can automate reasoning tasks, but you need to give AI the tool, right? The tool you train AI with. So you gotta have to give data to train the AI, but AI is like a baby, right? You gotta give AI the tools and train AI how to use a tool with its own reasoning. So what that translates to, and what we build in a cycle is that we are building these data and the tools before we build the agent, right? What is the data? The data is the contextual data from our entire application lifecycle, right? From source code to production, right? The code to runtime context, the application repository and developer context. So it's the contextual data we use to train the AI model that make a difference of how well the AI perform. The second thing is the tool I'm going to talk about. What are we teaching the AI agent to do at Cycode, right? well, what tool should AI use? Well, AI needs to learn about the contextual data, right, to what to act on. But think about exploitability, right? How do we actually look into the source code of a library or a custom code without some kind of detection tool to go in depth, right? How do we actually look at the data flow, source to sink, looking at all the sanitizing functions, looking at other mitigating controls without a tool that does detection, right? That's why we spend quite a bit of time since we acquired Bear to perfect our own SaaS engine. Now, obviously, customers don't have to use our engine for that SaaS purpose, but it's the call it the improvised perfected scanning or detection that goes beyond just normal SaaS to get that data for exploitability. Same thing with SCA, right? We have just about everything the other SCA vendors do, but it's the ability to look at that, look at the dependencies from the package manifest file, looking at the source code, using our source code, SAST scanner, looking at all that data, the ability to come to some kind of reasoning using additional context from environment, such as other controls available in runtime, right? You're using metadata to have that conclusion. So the secret sauce really at Cycode is that our agent can do advanced analysis in a very efficient and a way that scales because we got the components right, the data, the tools.
Yeah, those key components being contextual data, data flow analysis, understanding the application, all that comes from great detection capabilities, enriched with context across the SDLC. Yep, and that's what you need to really do exploitability analysis. So let's see what that looks like in action. Can you show us the exploitability agent?
Yeah, when I was on the other side, I would say, hey, proof is in the pudding, right? So
Proof
let's
is in the pudding, absolutely.
So we'll do a quick live demo, right? Obviously, Cycode is very capable platform. This is the reason why we do an ASP and first approach. So I'll share everybody the screen, right? So first of all, when I say contextual data, right, when we inventory the application, we figure out the relationship between repository to projects to owners and looking at everything across SDLC code, build, artifact, cloud, or runtime. So we can see what contextual data that our AI agents able to fetch from. Now let's get into our findings, right? Let's start with SCA, right? So I'll show you an example where I'll maybe debunk this, right? The ability to prioritize SCA findings, third-party library or custom or third-party code. I mean, itself, it's a big muscle, right? So if you think about examples of our, in my lab, we have about 10,000 findings, right? So in most modern tools, you can actually add in prioritization factors. There's no way a developer can act 10,000 findings. So if you look at the typical SCA without AI agents, there's exploit maturity types, right? Using mature exploits, you can see you can filter down to 41, right? That's purely using the public data. I talked about EPSS scores, KEV, right? Business context, those things. Very impressive already from 10,000 to 41. And then we add in another filter called the reachability, right? Actually, there's no reachability, but if I just get rid of the reachability first, get rid of the exploitability, adding reachability, 67. Still pretty impressive. Those are the tools that we already built for the AI agent to consume. So you can see that, I mean, it's already pretty impressive in terms of prioritization. But how do we know for sure that a portion of these findings have mature exploits or it's reachable? Just for audience, reachable means that there is a call, right, to this library from the source code that can be executed at runtime. But even then, you may not know for sure, right? So to me, these are table stakes now for a competitive scanning product, which we have. What do we do on top of that is the environmental context. So let me demonstrate our AI agents for SCA. So for time purposes, I have a finding that's assigned to me already. So let's look at our SCA findings. So let's look at this one, right? This SCA finding right here. So this demonstrates already what we already have before calling AI agents. One of the things that you can really look at is third-party library exploitability. With AI is that you want AI to have access to everything, right? So right off the bat, you see this one, the CVE 2022, right, is obviously a library third-party finding that has a known CVE dated 3 years ago. Before I show you anything else, let's go to the CVE right here, right? So you can look at a CVE database, looking at this finding. I just want to show you that this is a version in Spring, right, that obviously tell you which version is vulnerable. But look at this right here, regex request matcher. So basically, this vulnerability tells you that if you have regex request matcher using this function using this function, it can be misconfigured to bypass some servlet. Servlet means serve, right? So there's conditions, right? Applications using regex request with a dot in a regular expression are possibly vulnerable to authorization bypass. So if I translate this, means that this CVE database tell you for this CVE to be exploitable, it has to meet certain conditions. There's a couple conditions, right? So it's not just whether it's being called by the function, it has to meet these conditions. So let's get back to here. You see that we already have a lot of rich data from our own contextual data, right, and the scanning data. At Cycode, we use risk score versus CVSS in addition to CVSS to give that granularity. If you look at this finding, right, it's very interesting. You have a very high risk score, very high CVSS score, which is critical, 9.8. You have a very high EPSS, 90.7%. So right off the bat, the best SCA vendor in the market tell you, yeah, this one is certainly very critical. It's even reachable, right? Why is it reachable? We have it here too, reachability. So you can see, we look into the source code with many SCA tools today, they can see reachability analysis. You can see that regex request matcher is actually being used, right? You allocate another, this matcher is a new version of this, right? So you can certainly see that this is being used. So it is reachable. So going back to analysis, everything here tells you it's a direct dependency, right? If you look at our contextual data. So also another thing that our AI agents look at is, business impact, right? We look at the business impact, reachable dependency, high severity, moderate package health, right? Direct dependency, active repository activity, right? Because we also crawl the repository activity to make sure, hey, is this something that has not been touched in 3 months or 3 years? In this case, it's active. It's not archived, right? So basically, all those contexts saying it's reachable. But let's see if a developer spike to you says, I don't think so, or your DevOps team, ops team says, no, we don't have time. How do we know for sure? So this is explorability analysis, right? So with our AI agent running the analysis, first of all, it shows you all the thinking, right? So it gives you a verdict. Many of you may be shocked. Why does it say limited exploitability when you have a high EPSS score reachability? Well, let's show it, right? It tells you vulnerable is potentially exploitable, but specific configurations and settings for URL encoding is not explicitly provided, which means, remember I showed the CVE record right here? It means that AI agent is able to look at the vulnerability data, which you already have, and looking at other environmental contexts, other controls from other contextual detection to come to the conclusion that not all the conditions are met. So AI tells you this is the predictability, right? A lot of the AI agent complains that it's not deterministic. Well, this one gives predictability. You see, we talk about the dot character, right? So it has a dot character because AI agent is able to look at the source code, right, to show that there's a dot right here. So it meets the condition, and then the project uses a servlet, right, which is also true, but the prerequisite for exploitation includes the use of a vulnerable version of Spring Security, the dot character which we have, and the deployment of application on a server container allow alternative URL encoding. Well, the URL encoding, which is the third condition, that may not be met, so not provided, so we don't know for sure. So that's give you an example of the AI agent goes beyond just reachability, exploitability to kind of get into that context, right? So this one actually could be a false alarm, as in it could be exploitable, but it could be not. So now reverse can be true, right? If you think about this, there could be a low CVS score of a medium to low finding, but you run through this agent, it could be saying it's a high exploitability, right? So never take things for granted. This gives you a lot more granularity in terms of triaging and reprioritize. All right, let's go to SAST. So SCA, you can say it's easy, but this one's not easy. So same thing, right? Obviously, in order to do AI agent analysis, exploitability for SAST or custom code, you really have to use a very good foundational detection that looking at the advanced data flow analysis, looking at the data flow. So Cycode is obviously ASPN as well. So we can take data from developer favorite tool, right? So you might have an example where your developers are happy with SonarQube or any other tool. It doesn't matter, right? But the security team might be thinking, well, we don't want to piss off developers for telling them don't use it. But how can we do a trust but verify? So this is where we can use our analysis to look at enrich data from third-party scanners. So in this case, if you think about a custom code like SAST, by the way, SAST is not dead, right? You can all the factors, OWASP top 10, A01, which is ingestion attack, right? Dynamic import in the file path. It tells you exact line of code with description, look at the risk. First of all, you can see the risk score changed because in some point, the context is changing, so we elevated the severity. But same thing, you got a bunch of factors. But look at exploitability analysis, right? Not exploitable. Your developers will love that. If you show that to your developers, they will love you forever. Because everything else tells you it's a high severity, right? Going back to risk analysis, it's 100%, right? It's high risk. But why does it says not exploitable? Because require, right, this layer extract path, in this case a path injection, is not exploitable due to security controls and limitations in place. So our agent understood the context, saying that there could be controls. What are the controls that are not available in the source code? Well, it tells you that the potential attack path, in this case for injection, is path traversals, direct traversals, right? For a path, and not sanitizing your file path. But the code uses secure extraction directory, which is mitigation. The process extraction does not have permission to write outside the directory. So director permissions in additional context that in this case uses a blocker for exploitability. So in this case, it tells you because the IAM limitations, because of the controls, other environmental controls, using in this case a secure process, it makes it not exploitable or not likely. Right? So that's also very powerful contextual data to help you prioritize SAST earlier. Because when you start failing pull requests, failing the build, you don't want that to happen, where it's a high risk, and then developer come back to say, well, it's not, and then your ops team might be backing the dev team because they don't see any exploitability indications in runtime. So this is the demonstration of that. Interestingly, I want to show you one last thing. Is when I say context, right? So going back to this SCA finding, so what we have something also called let's traces, vulnerability data, right? Exposure path. So if we look at a graph, we can see tracing the this is part of the live demo, right? It's loading a little slow. We can trace the origin by looking at the repository it's coming from. But what the repository, what I'll show you is it show you all these other data, right? So the way our agent able to do is be able to show, right, look at this repository which contains that piece of code it has all these data, APIs, packages to give it a context, right? So if you look at the violations or findings of this repository, it has other environmental findings, which makes this even more risky with something called branch protection without pull requests. Those things, looking at the supply chain aspect of this, right? So our agent is smart enough being trained those data to further determine, adding the context of pipeline, the supply chain context, further determined exploitability. So here is, in a nutshell, our AI agents for exploitability analysis for both SAST and SCA or custom code third-party finding.
That's great. Really, thank you for showing us that. I know SCA specifically, the evolution of SCA from, all right, is there a vulnerable package to, all right, is that vulnerable function actually loaded? And for a long time, there's been a lot of focus on reachability analysis. I think this really highlights that it's not just if a function's reachable, but are all those conditions met to actually allow an attacker to exploit that? And certainly for SAST and CWEs, there's been long debates with developers of, all right, maybe this code isn't written in the most secure way, but there are mitigating controls in place. And anytime you can convey that truthfully with developers and build that trust, certainly something I think developers will welcome. So we've kind of talked about AI for exploitability analysis, because I think one thing watching the demo and even looking at you read that CD is a security engineer can read that CD, interpret those exploitability conditions, and then analyze the code. Tough to do that at scale across thousands of vulnerabilities. So exploitability analysis is a clear use case for AI. Curious, kind of what other use cases do you see for AI and application security?
Oh, that's a lot, right? We are at the industry. I think we are just scratching the surface, right? I'm a believer that AI is here. We have to embrace it. A lot of R&D experiment, right? So first of all, you probably saw earlier we have AI confidence score. So we want to continue to train the model. I mean, I certainly encourage the industry, whether it's organization, right, or other vendors, we should continue to explore. But just up until now, I think there's other low-hanging fruits that I'm seeing innovation. Obviously, as Cycode, we're doing that as well, right? So you see exploitability, but let's take a step back. Other use cases of AI, right? Before we even get to how to use AI to enhance app security, but AI is being used in app development quite a bit. So the first thing is we got to understand how AI is being used, right, in code. So I always think that visibility is the root of everything, right? You got to see before you can act, see and sense. So right off the bat, there's somebody call it AI SPM or just something got to be able to kind of detect how AI is being used in the environment. Oftentimes, security teams are always late to the game. If you remember in the cloud, right? When I was running cloud security, most of the time, cloud is already there for security team. AI is already here, right? So understanding that, so AI use cases be with inventory. Also, inventory also means you can create, export, like AI bullet material, right? AI bomb. Those are the things that's for first foremost. But we talked about detection. Oh, we talked about exploitability, which is kind of think about triage and prioritization. But detection remediation also have AI use cases. For detection, you can actually use AI to enhance the analysis. In this case, not exploitability, but using some kind of test case to see if it's a false positive, right? So using AI to increase the efficacy of your scanners, any detection. Lower false positive is one that we're also working on Cycode, but I think that's a very easy use case. The other use case where everybody talks about is remediation, right? Because fixing, prioritizing means nothing if you can't fix it. We have to fundamentally reduce the backlog. Even if we do the best exploitability analysis, we might still have too many and too slow to be fixed manually. So AI can be used for remediation, but the caveat is it's going to be difficult to break through beyond just the trivial, like which version to upgrade in a library. I believe true power of AI for remediation is that, again, you need the full contextual data, understanding who owns the chain of custody of that piece of code or artifact, where does it come from? So the AI can actually know where it goes going. And the power is, in addition to know the code context, if you see injection attack or insanitized input, the agent should be smart enough to create a piece of code that mimic the library, or mimic a sanitizer. But how does AI know, looking at everywhere else, that a sanitizer already not existed? How does AI know that there are other mitigations already in place? And AI should be able to, right? So we're going is looking at all these existing mitigations to see, well, are those strong enough? Maybe I should still write a sanitizer function, because these other things that AI detect is not strong enough. So there's so much to explore in terms of remediation. I think we're just getting started as an industry. But obviously, we are focusing on R&D in this space because we believe, again, there's so much potential in remediation. But the prerequisite is not just train the agent to remediation. The prerequisite for a better remediation agent is get better context, right? Code to runtime, better detection, better prioritization, better, more detailed environmental context, so that the remediation can happen. Remediation is easy, but what makes it difficult is what do we do with this context? And train the agent to be smarter with this context.
Yeah, super interesting. So even like looking at the output of the AI exploitability agent and even the kind of explanation of why something is or is not exploitable, using that as additional context, maybe to power better remediation. Really interesting. Well, I know we have around 12 minutes left. There are some questions that I did want to get to. Looks like we have a few. So let me take a look. All right, here's a question on, can you explain the difference between triaging, risk-based prioritization, and exploitability analysis? So I think we touched on that a little bit, but if you want to kind of cover that difference.
So triaging, risk analysis, right? Risk-based analysis, and then exploitability. So first of all, triaging is, in my definition, it's layman's term, is a time when a vulnerability or finding is detected to it's being resolved, right? So when you detect something, nowadays, developers don't trust anything. Nobody trusts anything. Too much noise, too many tools, too many findings. So triaging, to me, the clock starts for triaging. When you start triaging is that when you already know something, there's a new vulnerability already, having knowledge of an issue. Maybe it's an existing issue from a tool that you didn't have, or a new issue when you try to push code. It doesn't matter, right? So triage is the whole process of looking at this finding and do your analysis, right? Before you have a definitive action, whether it's resolve it by fixing it, whether it's call it, false positive, whether it's call it noise, whether it says accept risk because we have mitigation, whatever it is, that's kind of mitigation, right? So that's triaging. Risk-based analysis, to me, it is also it's a big question, right? You can talk for all day about that. I think risk-based, as everybody wants to, is looking beyond just what the tool that surfaces that finding tells you, right? In this case, looking at multiple factors. It's not just looking at the finding itself based on theoretical or public data, looking at how much real risk does this finding, issue, vulnerability, weakness has for my environment or for my application based on I define what those importance are, right? So risk-based analysis is what we need to get to. I think that our organization various maturity of that it's a true way to helping the triage process, because if you use risk-based analysis with the triaging process, it becomes more accurate, right? It becomes more tailored to environment. Where exploitability analysis on top of that is part of the risk, right? So part of the risk analysis is looking at exploitability of that particular weaknesses, combining the risk-based analysis is going to make the triaging process more efficient, faster, so you can get to resolution faster.
Right. Yeah, that makes sense. So all kind of interrelated, but looking at exploitability as a factor in risk-based prioritization and using that as kind of the driving force in triaging. Cool. Let's see. Another question is on AI exploitability analysis on every vulnerability seems untenable from a resource standpoint. So, what violations does Cycode perform exploitability analysis on? I think this is probably around, you could have thousands and thousands of violations. How do we pick and choose which ones we're going to leverage AI to analyze?
Yeah, Cycode is built for enterprise scale, right? So we intentionally built to scale, right? So uh, scale is not a problem, but also we have a lot of flexibility in configuration called configurability. Exactly to the point, right? What one organization, large or small, doesn't matter, um, care about might be different from the other ones, right? So um, we we focus on what's important. So some customer can say, well, I have so much noise, right? With just filtering my findings across all the tools, just with criticals and highs, it's just not enough, right? Even some new gadget they bought from new SCA gadgets as reachability and EPSS, still too many. I personally ran a POV with a large customer. They have over a million SCA findings. If you're just adding these filters, everything what I talked about, it's just still thousands. So in that case, that can be used at scale across those findings that has critical business impact on their high value applications. Another case could be the opposite. We have people always they call it the deep. I call them researchers, right? People don't believe the hype of tools. They want to dig and dig. I also have customers who rightfully said because they say, well, all the vendors nowadays that does third-party library, security check SCA says they're reachability. Reachability is not end all be all, right? But what do we do? How do we ensure that from a 0 day prevention perspective, can we detect 0 day before it happens? Because something might be reachable, not reachable today, maybe reachable tomorrow if there's a code change. If you already input a library, just adding a code change, calling a library tomorrow, what do you do? So in that case, we can also use AI exploitability. I showed you earlier. Something reachable doesn't mean they are exploitable, but the reverse is true. Something not reachable could be exploitable, right? So there's cases where there could be some high value application. They know it's business critical. They don't purely believe the their SCA tool. It says non-reachable. It could be a medium to low CDSS score, but something about that CVE they just not sure about. So we can use that too.
All right. Yeah. So variables can change, and you need to analyze and have confidence that the tools are accurate and that things are actually exploitable. Makes sense. Looks like we have one more question. You showed models for exploitability analysis for SCA and SAST. Any plans for additional models? So additional exploitability analysis capabilities.
Absolutely, right? We believe in code to runtime context, right? So application can be in many forms. Obviously, we try to avoid um, you know getting to that agent without proper training using contextual data. So the big thing is that we have the data, right? We got to get more data with training. So can't show right now, but the idea, right, is um, more better models, agents looking at again the when we think about application security, application has many forms, right? And source from source code to supply chain artifacts being moved around the deployment process, also running applications. So we're trying to add more models, add more capabilities. In this case, sometimes it could be a configuration in your cloud, or infrastructure, programmable infrastructure configurations that may have mitigations that we got to figure out, right? So for container, obviously, is something that we are looking into right now.
Okay, great. Um, doesn't look like there are any more questions, so I think we'll wrap it up there. Jimmy, as always, thank you for sharing your knowledge and insights. Thank you as well to everyone who joined and asked questions. If you want to learn more about Cycode, the AI exploitability agent, you can read customer case studies, etc. Check out cycode.com. With that, I'll say thank you so much for joining. Thank you, Jimmy, for being with us. We hope to see you all at the next webinar.